My name is Thomas Watson. You can find me on Twitter and on GitHub, where I do a lot of open source stuff. And when I don't do open source stuff, I also do open source stuff for these guys called Upbeat, who are also sponsoring today. That's really cool. And what I do for them is I work on their Node.js agent that tracks your Node app in production and figures out the performance of it and graph it and do nice things. But that's not what I'm going to talk about, because what I'm going to talk about is what happens when you use a tool like this and then you figure out there's a problem. How do you debug the problem when it's a really nasty one? So that's basically what my talk is about, debugging Node.js in production. So why is that important? A lot of times you can probably have some tests that will debug, basically make sure that your things are working, or you can reproduce a problem locally maybe. It's a way easier solution if you can do that. So if you can do that, by all means, do it locally. But sometimes it's really hard to do this, to reproduce the problem locally, maybe impossible. You need to figure out what's going on. Why is my app slow? I can't really figure it out. When I run it locally, it's fine. When I run it in production, it just becomes slow, or it crashes at weird times, and I don't know why it crashes. So why is that harder? Well, it's harder because your app is in production. You have live customers who are depending on your app to be online, and you don't want to affect the performance of it. You can't just enter up the node inspector and pause the entire process to debug what's going on inside your process. So you need a way to kind of get access to the process, but without slowing the process down. And before you start all these things, I want to say like one thing that is like really important and of course dear to me, which is having a way to have a baseline performance graph. So how do you know that your app is slow? Well, if you wait until your customers call you or shout to you on Twitter, then it's too late. What you want to do instead is you want to know what your app performs normally, and then when you do a deploy, you want to be able to see this change. Oops, all of a sudden like 20% slower or something. So that's why it's really important, by what any means you want to log the response times of your app, so you know on average what should your response times be like. So what can be the causes of slowness? We all know that the Node.js is single-threaded. Some of you might know it's single-threaded. And that's not necessarily a cause of slowness. I put it in parentheses because it's something we have to work around. Of course, we can boot up multiple processes, but the individual process still is single-threaded. So that is a problem if you have some CPU-intensive code, some code that runs on the CPU, doing some computation of some sort. While it's doing that, your Node app can't do anything else. If there's incoming requests to your web server, they just have to wait until you're done doing the CPU-intensive code. So another thing that can slow down your app is slow I/O. So that's like talking to the database, talking to an external API. That doesn't slow down necessarily the rest of your requests, so all the other requests can still be processed at this time because it's asynchronous. But that individual request will still sit around and wait for your database to respond or whatever. So what happens then when you get too many requests at the same time? None of them are like blocking, none of them are doing any CPU-intensive code, but you're just firing so many requests into your system that are doing so many asynchronous things, so the Node.js event loop simply gets saturated. It can't complete the tasks, it can't dequeue stuff from the event loop fast enough, and more requests are coming in than are going out. And at some point, you'll start to see that things just, like you set a timer for like do this in 10 milliseconds, and it maybe take 30 milliseconds before it's done because it just can't keep up. And then finally, of course, you need to have enough memory. So before you do anything else, if your app is slow, check that you have enough memory, because by default, Node.js on a 64-bit system will only have access to 1.7 gigabytes of memory. and maybe if you're running on Heroku, like their default dyno is like 0.5 gigabyte of memory. And Node.js is really good at managing the memory, but it will wait until it uses V8 internally, and the V8 garbage collector is a kind of like a stop the world garbage collection system. So it will wait until the very last moment when there's no more memory available to the node process, and then we'll say, oh, I need to clean up memory. And while it's doing that, you have is just stop, nothing is happening. So make sure that you have enough memory. That was the garbage collection thing I was talking about. So what I want to talk about today, to begin with, is CPU-intensive code. How do you debug CPU-intensive code? What is CPU-intensive code? That can be synchronous I/O instead of asynchronous I/O. That's a no-no in Node world. You want to do everything I/O. You want to do that asynchronous. It can be JSON parse. So your client is sending up a large JSON document to your system. You're parsing it. That's all synchronous. If it's a 1 megabyte document or something, it might take a little longer than when you test it locally with just a few hundred bytes. Regular expressions. Normally, regular expressions are really fast, especially if you compile them beforehand. So you say new regex, and then you reuse the same compiled regular expression. Just test on that. But you can have some situations where regular expressions can take exponentially longer time to process based on the input. It's called a redos attack, and it's really, really hard to figure out if your regular expressions are susceptible for redos attacks. But that's also something that can slow down your code, and that also runs on the CPU. Crypto is something that runs on the CPU. That's a lot of math that can be really heavy. If you're generating HTML templates, if you have HTML templates and that are generating HTML, if you're running in test or development, and you're like, okay, I have this like list of products or search results on my search page, and then there's like 10 results. It renders for like really, really fast, like 10 milliseconds. Then some asshole on your live production application searches for anything that has the letter A in it, and you have like 2 million products, and it tries to list them all and tries to generate that. That also runs on the CPU, and that can become really, really slow. And this is by no means a complete list, of course. So we have an idea that there might be something CPU related going on in our production app. But how do we inspect what's going on the CPU for this given process, for the node process? How do we look inside the CPU and see what is the CPU actually doing at this very moment? So normally when you want to see what goes on inside your node process, you look at a stack trace. Like if an error happens or if your server crashes, you get a stack trace. So a stack trace is a really useful way to figure out what goes on inside the CPU. So it would be nice if we could sample stack traces. Like just ask the CPU once in a while, hey, what's going on right now? And if we could bundle up all these stack traces, we can get an idea of what happened at given points in time on this process. And if you're running your server on a Linux machine, which most of us are, there is a tool called perf, which has been around for a long time. It's a way for you to ask any process, or the entire system, the entire kernel for that matter, what is working on. And you can ask to go into record mode. And then you can say, I want to sample 99 hertz. So I want to take 99 samples per second of what goes on inside a process. And you can give it the process ID that you want to sample. And you can ask it to capture these stack traces. And you can say, do this for 30 seconds. So look at this node process for 30 seconds, and 99 times a second, take a stack trace. And this is very, very lightweight, even though it sounds not when you do it 99 times per second, but it's very lightweight. It runs outside your node process. It's just talking directly to the kernel. So it doesn't really affect the process of your system. when you run this, it will generate a file in your current working directory called perf data, and that is basically a huge file of, in this case, 99 times 30 stack traces. So it's all the stack traces that it made. And if you just run this, then you get like a sample. If you look at like one of the stack traces, you can run, after you run this command, you can run perf script, and perf script will just list all the stack traces that it collected. And since this is not a JavaScript stack trace, this is not running inside V8, this is actually running on a much lower level. You will also get stuff from inside V8, you will get stuff from the Node C code and stuff like that. But then you'll get this weird blank stuff in the middle, unknown. And that is actually your JavaScript stack frames. And we can't really use that for anything because unknown, you have no idea what's going on. And to the left of it, there is like a lot of memory addresses where these pieces of code that is running is in memory. And the reason why it doesn't show us anything about the stack frames is because JavaScript is just in time. So it shifts the functions, the code shifts a lot around in memory. So from outside, we can't really know what's the name of the function and which line number it is. So we need to ask the node process to dump some metadata that perf can use to be able to understand what's going on. And luckily, you can start your node process with this flag called perf base prof only functions. It's a very long flag. And it has like a very little overhead. You can run this in production. There's no problem with that. It won't really slow down your app. And when you do that and then run perf script again, you suddenly get JavaScript stack frames. And you can even see here stuff like this is on CPU JS line 4. So this is actually the JavaScript code that's running, and then line 13, etc. So this now looks like a normal stack trace. Normal. So, but how do we go from having these thousands of stack traces to then figuring out what is the CPU-intensive part of those stack traces? So for that, we want to render something called a flame graph. And a flame graph, besides looking really funky, is basically a lot of all the stack traces combined into one graph. So on the y-axis here, we have stack frames. So each of these is a stack frame. And on the x-axis, that's not passes of time that some would think that it would be time going, like that would be like the 30 seconds or something. On the contrary, it's just a representation of how often it's seen a given stack frame. So you will see stuff here. This is not a node process. This is just the MySQL daemon running, and this is what goes on inside MySQL. But you will see that, okay, it saw this specific stack frame a lot of times in all these samples that it took, but it saw that stack frame up there maybe only once in all the thousands of samples that it took. So if it saw this one way more than it saw that one, it must mean that this one is taking up more time on the CPU. It could of course also just mean that it's being run a lot of times, and each of the times it doesn't take up that much CPU. But most of the time you will find that it's actually because it's like running for a long time. So if it's running for like 100 milliseconds and you're sampling a lot of times, then you'll see it a lot of times as well. So let's try to do this. So actually, let's see. Okay, nothing is happening right now. That's good. There we go. Okay, so I have since this is something that doesn't run on OS 10, I have a Ubuntu server running here. I'm just gonna log into my Ubuntu server. And I have prepared a little program here that, of course, have a problem in it that takes a long time with CPU. So we're gonna run this server, and I run it with the perf base prof only functions flag, and I run it in the background, and then while that is running, we're gonna let's see, where do we have that? I could just type it. In this case, we run it as a sudo perf record, and we say let's sample 99 frames per second, and let's get the PID of the latest node process that was started, and get stack traces and do it for, let's just say, 10 seconds. And before I press enter there, I'm just going to go over here, and I'm going to prepare a tool for, let's see, I'm going to prepare this. I'm going to use autocannon to just fire a lot of requests towards the server, so it's actually doing something. So let's run this. Oops, it asked me for my password here. And let's prepare. There we go. Enter, enter. So, I know it's a little hard to see here, but it's firing a lot of requests to the server, and it's done. And we can see here it could fire like 0.9 requests per second, so that's not really that fast. That's of course because our CPU is wasted doing something here. And at the same time, what it did was, because Node was started with this flag, if we look inside our temp folder, it created a perf file inside our temp folder. And that perf file is the one we're going to use to make perf know how to interpret the I mean, you should just, oh no, that's things like this. We need just to change the user of this one here, so we have access to it. Okay, so now we want to generate a file that we can use to generate the flame graph. So we need to just convert this file using the script. So the perf script was a command to like just list all the stack traces. And we just list all the stack traces into a stacks.out file. Boom. So now we have a stacks.out file. And then we go over here to my own machine, and then we just copy the file, the stacks.out, to our local folder here. Oh yeah, I have to write the right folder name. There we go. So now we have that. And now we use a tool that I installed previously called 0x. It's a tool that you can install from npm. So npm install 0x-g for global, and that will generate a flame graph for you. So we write 0x, and then stacks, and then flame.html. Okay, and then we open that in Chrome. See if we can get this a little bigger. Oops. So this is a frame graph of all the 10 seconds worth of samples that we took. And this is like 0x makes this nice interface where I can switch off let's see the V8 stuff. So it adds the V8 frames, or we don't want to see the V8 stuff. We don't want to see the native C stuff, and so we can filter the stack frames and only get like the JavaScript frames that we want. Or we can click on any of these, and then we can like zoom in and see what goes on here. But if we look at our code, then it's fairly obvious that this part here is our code, CPU JS line 13, and just above that we can see we start to go into some Node core stuff. So on this line in this file, we are calling, in this case, a hashing function to hash a password. And we can even see it in the name. It says sync. So apparently we by accident used the sync version of this really expensive function instead of the async version, and that's of course why I then spent a lot of time on CPU and blocked the entire process. So all we now need to do is go back into the JavaScript code and change it to a asynchronous version, and then resolve it. So this is of course a contrived example, but it gives you an idea of basically where is it that, and I actually do it like 2 times here. So I have like 2 paths. I have a foo function and a bar function apparently, and both are generating some really, doing some really heavy math. So I have no idea how much time I have left. Do we know? Okay. So another thing that can happen is that your app is crashing and you have no idea why. And when an app crashes, you get a stack trace, but the stack trace just tells you, okay, it crashed to this line. And maybe like an error message, but sometimes it's related to like what were the variables that were on the stack at this point. Like the function was called with a variable that we didn't expect, or the user sent some data that we didn't expect. So in those situations, it's really, really hard to reproduce the problem. We have no clue why the app didn't have the data available that we expected it to have. And in those situations where we can't reproduce the problem locally, what we instead can ask Node to do is generate a core dump. And a core dump is basically the entire memory of Node.js just saved into a file. So that's like all your heap, all your code, everything. And then we can analyze that core dump and actually go in and see, okay, what was the state of the process when it crashed? Like what was in memory? What was the variables that were in memory? And we can use a tool called MDB. And MDB is a tool that originally was made for Solaris. And it doesn't really run anywhere else in Solaris. So that's already there, like a big roadblock. There is a lot of open source Solaris alternatives that is Solaris compatible that we can run it on. And just as with perf, MDB needs to know to understand what is JavaScript and how does JavaScript objects reside in memory, and how does the JavaScript stack trace look. The MDB is a really extensible tool that you can write a lot of plugins for. So there's a plugin for it to understand Java. There's also a plugin for it to understand V8, aka JavaScript. And all we then need to do is when we run our Node server, and this is again not something that is really a problem to do in production, it doesn't slow down your app. We need to run it with this flag called abort an uncalled exception. It sounds a little wrong because of course you always abort an uncalled exception, but what it actually means is it will actually dump a call file. And then MDB also needs the node binary. So of course you need to give the core dump to MDB, and you also need to give the node binary to MDB. So you need to copy the actual binary from your production server that is running, so MDB can use that together with the core dump to figure out what's going on. So I don't have a Solaris machine, or most people don't. In this case I actually do. But most people don't have a Solaris machine. So how do you get a Solaris machine? Well, you can do npm install, as you always do to fix a problem. npm install autopsy globally. And when you install autopsy, Then you get a command line tool called autopsy, and you run autopsy space setup. And what setup does, it will, from some S3 bucket somewhere, it will fetch a Solaris image. And it will expect that you have VirtualBox installed. VirtualBox is a nice tool for you to be able to run Linux and other stuff on your Mac or on your Windows. And I have VirtualBox on this one, and the Ubuntu machine you saw that I logged into before, that was actually running inside a VirtualBox. But I also have the Autopsy Solaris running inside the same VirtualBox. And then you just write autopsy start, and it will start up the the VM for you. And it will give you a nice command to be able to copy the core file and the Node.js binary into this VM. And it will actually also start up MDB for you and load the V8 plugin and all that stuff, and just give you a nice prompt where if you know what to type in the prompt, it's kind of like you have from a REPL or whatever. Then you can query MDB and ask it to tell you, okay, what actually happened with this core dump. I'm going to show you that real quick. So I feel like maybe I should take this because I don't think that everybody can see the button up my screen here. So let's do it like this. So we have this. There we go. Okay, so what I want to do now is basically just tell the operating system that I'm running the server on to allow core dumps to be created. By default, a Linux operating system will not allow this because it can take up a lot of hard disk space, and you don't want to run out of hard disk space. So I'm just going to tell Linux here to just allow unlimited sizes of core dumps. That's cool. Then I'm going to run Node.js with board on chord exception. And I'm going to run the crash.js, which is basically just a server that have a problem in it that we want to fix. So now that's running. I'm going to go back to my own machine here. And then I'm going to just make a post request, if I can spell. I'm going to make a post request to the server. And I'm going to send up some JSON to a sign up endpoint. Application JSON. And I think it's called that. And so I have, this is just a JSON file that I'm setting up with my sign up information, my name and stuff. Port 3000, sign up. Okay, empty reply from server. That actually means that the server crashed. We can also see if you go back to the server here, there was an illegal operation, cannot be properly first of undefined. We've seen that a lot of times. And it says core dumped. And if you look inside this folder, there is a core file. And so what we now do is we basically just take the core file, core, and we also take the Node.js, which one is that? User bin Node.js. The binary used to generate the core, user bin Node.js. Okay, I have that down now. And then I run autopsy, and then the node. There was. I can actually let's first check status. VM is up. That's good. Okay. So and then it's right Node.js and a core. And what it will do now, it will upload the Node.js binary and the core to the VM, and then it should give me a nice little interface here, but it doesn't. because there's a bug in it right now with my version of Node. So what I'm just going to do instead is just going to log into it and basically localhost do the same thing that it's doing. So I'm going to run mdb. Actually, and it put the 2 files in my current directory, so it's really nice. mdb node.js core. And it says, oh, I don't know about this stuff. So I'm going to, no problem. Just load V8. Okay, cool, V8 is loaded. And then we can start to ask it stuff about the core dump. So what we, for example, can do is we can say, okay, let's look at the stack where the core was dumped. We need to, everything needs to start with 2 colons for some weird reason. There we go. So now we actually see the stack of where we stopped. Remember, it was like around line 14 or something on Crash.js, and we can see that this inside the function that we were in was set to undefined. You can see there was 2 arguments to the function, the unsafe function, and the first one was null, and the other one was an object. Okay. Let's actually look at the object. So we can just take the memory address. So all of these are like memory addresses of where these properties are in memory. So we can just take the memory address now, and we can just ask to look at it. So JS print. And we can actually see, this is the JSON that I sent up to the server. And we can see it's trying to get to the, remember, like the error message was cannot access first on undefined. And we can see I probably have a spelling error here because I spelled name with 2 A's. So it's trying to access, if you look at Crash, we can see down here, it's trying to access name.first, and I spelled it name with 2 A's. So the user sent up some garbage data, and now we can actually see what happened. So that makes it really, really easy. And there's like tons of stuff you can do with this. I'm basically just scratching the surface here. But Venya looks like I'm out of time.
You look like you're out of time.
Okay. So I am just gonna find there we go. And that's it. That was my last slide. Thank you.